Okay. Strength is very less today. Only 18 students. Londe Jairam. Jairam Londe.
Yes, sir.
What is the time and at what time I have posted the link? Files all great. After putting the message only will join means horrible thing. क्लास कितने बजे को छोड़ दिया पहला लेक्चर? Continuously you are attending, already the link is there, previous class we have attended, then how much time it will take to switch from over there from the first class to second class? Hardly 1 minute. Okay, so we'll start. Yesterday I have already given we have started in the previous class, that is the unit 2, that is called harmonics. Okay, so the harmonics we have started already, the objectives of this chapter, outcomes of this chapter, and this is the unit content here. So directly the actually syllabus is starting from harmonic sources, from commercial, industrial loads, and all the things we have started. Okay, previously have you studied, anyone can you clarify me, have you studied what about the harmonics and all the things? In the first unit we have discussed about the, what is that one, only definition. Have you seen any waveforms of harmonics and all the things in any subject? Clarify me, anyone. Then I will take the introduction. Otherwise, I will skip that part, introduction of harmonics. बोल सकते क्या? Machine. Which one? Machine, electrical machine. You have studied about harmonics.
Electrical.
Okay. So have you studied about that first harmonic, third harmonic, fifth, seventh, and all the things? Yes.
7th and 5th.
Yes, sir.
Okay. That at least you know the types of that one. Okay, no problem then. So then little bit I will add, and other things skip over that. So this is the actual syllabus of the second unit harmonics. So we have already discussed that the harmonics are sinusoidal voltages or currents here. So these are the sinusoidal, the AC voltages are currents here now. This one actually, okay, it may be current or voltage, having frequencies that are integer multiples of the frequency at which the supply system is designed to operate. Our supply system is already designed to operate at 50 hertz. Okay, our system is already designed to operate at 50 hertz is there, but if integer multiples of that one, multiplication of integer multiples means we are going to multiply that, the first whatever the fundamental frequency is there, that is first harmonics. Next we will go for third. So that is, we can consider 1, 2, 3 also. 1, 2, 3, 4, we can consider that one. These all are the harmonics only. In that one, the odd harmonics are very harmful. We can consider that one here. So what are these integer multiples means? I will tell that one. What is our fundamental frequency? 50 hertz is our fundamental frequency. So this 50 hertz which the system is operating, that one also we are going to consider. Into 1 is nothing but 50 here now. We are going to consider this is the first harmonics. There is no effect, that is clean and sine waves we are going to use here. Clean sine waves we are going to use for this. If it is multiplied into 2, if it is multiplied into 2, how much it is? 100. Okay, 100 multiplied into 3, that is called 150. Like that, the integer multiplications, it is going to continue that here now, 150, 200, like that. So continuously it is going to integer, it is going to multiply here now. So on that condition, the time taken to complete one cycle is called time period. Yes or no? How much time it is going to take to complete one cycle, that is called time period here, no? So actually this periodic fundamental frequency time period for that one 50 hertz is there. Okay, if it is suppose same during this time only, suppose it will, the waveforms will come like this here. Here only it will come like this here. It is double now. It is double. How many wave cycles are there here? 2 cycles are there. Here 2 cycles are there again. That is fourth harmonics, we are going to call that one here. How many cycles are there inside during the same period? How many cycles are there? 1, 2, 3, 4 cycles here. That is called fourth harmonic, we are going to call here. If only 3 cycles are there, this positive, negative, here positive, next here 3 cycles it is completed during that, it's called third harmonics, we are going to call that. So like that, it is a integer multiples of the frequency at which fundamental frequency or the system frequency we are going to consider. Periodically, distorted waveforms can be decomposed into sum of fundamental frequency and the harmonics here. So this is the harmonics actually. This is harmonic waveform. This is the fundamental waveform here now. Yes. So the distorted waveforms will be like this here now. I will show the waveform also. So like this, the harmonics, like this, they are going to come here. The like this, the fluctuation, this is called distorted harmonics, distorted waveforms we are going to call that. The combination of harmonic component plus the periodic waveforms are there. These are called distorted waveforms we are going to call it. So what is the problem of the harmonics? The harmonics can increase energy cost here. No? So we are not going to get pure sine wave. Then the components will be fluctuation in the voltage and current over there. So what will happen? The heat will be occurs in the current circuits or conductors over there. So by continuous increasing the temperature, the lifespan of that product will be decreases. So like that. So some this harmonics is nothing but some fluctuation is, that means that is only loss only here. No. So energy cost for that loss also you have to pay. So that is energy cost, and reduce the lifespan of the hardware. In some cases, harmonics can overheat the electrical conductors here. It is going to overheat and creating a fire risk over there. If the heating is increased, then insulation will break. If the insulation flashover occurs, then what will happen? That is fire may occurs over there. This is just brief introduction about the harmonics we are going to call it. See here, this is the periodic waves or clean or distorted. We are going to call that one distorted waveforms here. So we will consider mathematical concept called periodic wave here. Now the graphical representation I will see here. Now this is the periodic waveform here. Okay, so the time taken to complete one complete cycle, that is called time period we are going to call it. That is also called as wavelength we are going to call it. This is the wavelength. So from 0 it has started and half cycle and another negative half cycle here. Now this is called the periodic wave, that is fine waveforms we are going to call that one here. The finely it is sinusoidal is that here. So period equal to time to complete one cycle. That is called time period here. Now this one is distorted. Same, there is no frequency at all here. No, same thing is there, but some harmonics are added inside this one. We'll tell that one later. We'll tell that one by taking the with all the waveforms. We'll tell that one. So let's consider a mathematical concept called periodic wave. We have already considered this one. We are going to consider. Okay. So this is graphical representation of a constantly changing variable whose values follow a repeated sequence here. Here I have drawn only one cycle here. So n number of cycles is going to draw that one here. So for per second, how many cycles it is going to complete? That is called frequency equal to number of cycles completed per second. We can call that one here. So inversely proportional to the time period here. So that one, it is continuously. I have shown only one waveform, but one cycle I have shown. It is continuously. It is going to repeat for the another. For the next cycles, it is going to repeat that one. When we examine a sine wave, one of the first thing we notice is that it follows very symmetrical and repeated pattern here. It is symmetrical only here, no? Same thing here. You have observed the next waveform will be same only here, same like this one only. So whole complete waveform, it is symmetrical only. Same thing it is going to give the output over there. So symmetrical and a repeated pattern here now. Same pattern it is going to repeat here. Each full wave has a certain length here now. It's called wavelength. We are going to call this whatever the from 0 to here where the one cycle is completed, that is called wavelength. We are going to call here. This is called wavelength here. So each full wave has a certain length, that is called its wavelength. Its wavelength. The time required for one wavelength to complete its cycle is called period here, or time period we are going to call that. Time taken to complete one cycle. So half positive cycle, half negative cycle, that is called one cycle we are going to call here. No? So that one we are going to call as time period we are going to call, from which we derive the term that is called periodic wave here. No? That is called period, and the waveform of that period, particular period is that is called periodic wave we are going to call here. So the periodic waves are found in a wide variety of natural phenomena, including ocean waves, how it is going to sound, light, and electricity. So electricity transmitted over a public power grid can also be graphed as a periodic wave. Whatever we are transmitting the power, electrical power, that is also the periodic wave only we are expecting here. But what will happen? For the continuous in the real, it will not be periodic waveforms we are not going to use. So some harmonics will be produced, some losses may be over there. Because of that one, we are going to get the distorted. So a perfectly regular and symmetrical sine wave, this one represents very simple and clean example of periodic wave here. Now it is very simple here. You can draw positive half cycle, negative half cycle, and there is no disturbance at all, anything here. In the real world, actually in the real what we are using here now, however, periodic waves are subject to numerous influence that affects their shapes over there. So many problems will come. Suddenly overload will come, voltage distortion will occur over there, higher voltages. Suddenly we are going to remove the wave loads. We are going to do any practicals and all the things here. Some converters we are going to use. So like that, by using that one, it affects their shapes over there. Whatever the shape is there, it will changes over there here. These can produce waves that display distortion and asymmetries here. No, it is symmetric hai kya? Nahi hai. So it is here increased, here decreased, here increased, like that. This is asymmetric. Where it went? Asymmetric and waveforms we are going to call. That is called distorted periodic wave we are going to call. It is distorted here. Now disturbed also we can call that disturbed. How we got this waveform, I will tell in the next diagram here. Now by showing the next diagram, I will tell this how we got this waveform. समझ में आ रहा है क्या नहीं? Hello. This is general only. This is general only. I am telling here now. So ये study किए क्या? Distorted waveforms and all the things. Machine में यही same cover हो गए क्या? कोई तो reply दे दो. ठीक है. So what we are going to do? these waves are there. How we got this one upside, low side here? We have to deconstruct that one here. We have to deconstruct. Our expectation is we have to get this one. Okay, this is the periodic wave. We have to get like this. But we are in the real world, what we are getting? We are getting a waveform like this in the distorted periodic waves we are getting here. What is this here now? It is up, it is down here now. Why it is considering coming like this? We have to, what we have to do? We have to deconstruct this one here now. We have to draw this one, and this part we have to draw separately. Deconstructing distorted waveforms here. How we have to deconstruct here now? See here, I will take that one. From now onwards, who will join, I will admit all of them, but I will not give the attendance for them. Okay, so see here, so this is the distorted waveforms is there. This red color is there, that is actually periodic is there. So from the periodic, we have got distorted waveforms here. Distorted waveforms, how we got that one? Because of, that is because of the harmonics are present here now. Because of harmonics present here. See here, at this point, see here, positive cycle of the harmonics, it is increased here now. It came harmonics here now. For that reason, the periodic wave is like this, but it has, because of the harmonics, it is increased here. For the negative of the harmonic cycle, harmonics, it is down now here. Again, the up is there here. So this blue color line, it indicates harmonics here now. Harmonics and the periodic waveform here now. This is the red color and blue color. It is going to give the harmonic and the periodic here. So the combination of this harmonic and periodic waveform, it is going to give the distorted waveform here. Distorted waveform here. So we'll check that one. We'll check once again. I will take the red color here now. See, up to here, one half cycle is completed here. One half cycle is completed. Up to here, that is complete cycle is. So this is periodic waveform here now. Periodic wavelength we are going to call here. In this periodic wavelength, how many cycles of harmonics it has taken, we will consider that one. See here, this is up to here, this is one cycle. From here to here, this is another cycle. From here to here, this is another cycle here. So this is 1, 2, and 3 here. 3 cycles are there. So for that reason, this is integer multiple, that is called third harmonic we are going to call here now. This blue line, it indicates third harmonics here. So the combination of this third harmonics and the fundamental frequency waveform, 50 Hz frequency waveform, that is called. So we are going to get the distorted waveforms we are going to get here. That is called distorted waveforms here. The same thing I have explained here. To understand how this happens, it might be useful to work backward and deconstruct this wave into its constituent components here now. To understand how we got the distorted waveforms here now, this distorted waveforms, we have to deconstruct this one here. How to deconstruct? First, we have to draw the fundamental. Then, why it is up? Because of the harmonics. Why it is down? Negative cycle of the harmonics. Like that, up, down here, we can draw here. A periodic wave, no matter how it is distorted, can be defined as the composite of single primary or fundamental wave and one or more so-called as harmonic waves of the varying wavelengths here. See, harmonic waveforms, this wavelength of the harmonics is here only, this much only. But for the fundamental, the harmonic wavelength of the fundamental frequency or fundamental waveform is up to here. Up to here is there. Okay. So our illustration can be deconstructed into two waves here. Whatever the distorted waveform is there, this distorted waveform, we are going to reconstruct or deconstruction into two parts here. Two waves we are going to consider here. First one is the fundamental wave here. The fundamental wave means what we are going to do, we are going to draw this one. I will take. So first I will draw the fundamental frequency को waveforms कितना था उतना I will draw that one here. This is the fundamental wave here. Okay, two waves, the fundamental wave and harmonic waves here. Now, harmonic waves I will take that one as which one? Blue color only I will take here. So here the harmonics will start from here and start from here, and it is going to start here, and then like this it is going to end here. Like this it is going to end. This is called harmonic waveforms. We are going to call that. This is harmonic waveforms. So combination of these two, we are going to get the distorted waveforms. We are going to get that one. How we are going to get the distorted? I will take the violet color. Where is the violet color here now? The violet is not there. So I will take the white color here. Okay, I will take the white color here. So here the fundamental only it is going to stop here, and the complete cycle total wavelength only it is going to stop here. I will start from here. First this one plus this upside up to here, what it will do, it will take and it will go up over there. So how it is going to do for the, because of fundamental it will start, because of the harmonic it will increases and it will start decreases. Like this it is going to come for first job cycle. Next again the downside, it is also same thing, it is going to happen like this. This is called distorted waveforms we are going to call. So whose wave length is 1/3 of the fundamental here now. So fundamental is here 3 is there, that is 1/3 of that one, that is going to call, it is going to the harmonic wavelength is there here. So this second wave is therefore called the third harmonic. So combination of these two, that is called fundamental and third harmonic, produces the distorted waveforms in the example. This is the distorted, this one is distorted here now. Okay, so this one is fundamental, this is harmonics here, harmonics. So wavelength of this one I will consider as 1 here now. This one I will consider this one as 1 second. I will consider, see here, I will consider as 1 year now. 1 cycle ko 1 consider karta. But see in the day same duration, the harmonics, how many cycles are there? Here 1 cycle, just a minute. Here 1 cycle, it is nothing but second cycle and third cycle. So 1 divided by 3 we can consider this one 1/3. The wavelength of this harmonic is 1/3 of the fundamental frequency here. 1/3 of the fundamental frequency. We can say that one. So this is the basics of harmonics. So if you, instead of this is 3 cycles, if it is 4 cycles, then 4th harmonic, 5 cycles, that is 5th harmonic. So integer multiples we are going to call that. Okay, this is the concept of harmonics. I am explaining only the concept, how we are going to waveforms will changes over there. Actual sine waves we are not going to get. Why? Then what are those places where it is going to occur? What is the solution? We are going to discuss in the second unit. This is out of syllabus only because it is required to understand the harmonics in it. This is the basic need. For that reason I have taken here. Just a minute, I will connect the charger. Understood? Any doubts? Same thing study किया था क्या machine में? Can you reply anyone? Have you studied same thing in the machine subject? Any one of you reply, please.
No, sir.
And what you have studied in the machine too?
Only basic part of harmonics. Third harmonics, fifth harmonic, seventh harmonic.
So directly went for the 5th and 7th harmonics. उस टाइम में मालूम था क्या harmonics means क्या है बोल के? So now it is clear. 7th means, so in 1 cycle, ये same period में I will draw the 7th harmonics also. You can see, check that one. Okay. Seventh harmonics I will draw here. So this is the period is there, total wavelength of the fundamental frequency. So here we have to draw 7 waveforms here. 1, 2, 3, 4, 5. No. 1, 2, 3, 4, 5, 6, 7 here. This is the seventh harmonic. For the seventh harmonic, the distortion wave output also it is going to change over there. It is going to come like this here now. It will up to here, it will move same like this here now. Here it is going to like this. So for what is that one? 3.5 either or 3.5 either aisa ho jata. So this is distorted waveforms for the seventh harmonic here. This is called seventh here. I have the diagram later. I will show that. This diagram I will show that other harmonics are also there. See here, this is the seventh harmonics. The blue color line is there. 1 cycle, 2, 3, 4, 5, 6, 7 here. That is called seventh harmonic. So this red color, it is chocolate color we are going to consider. That is fundamental. So for the seventh harmonic, see here now how the waveforms, the distorted waveforms, it is there here. Going up, down, up, down, up, down like this. It has taken here. So this is for the, so this is third harmonics. This is for the fifth harmonics. This is for the seventh harmonics here. So this is the introduction of the harmonics here now. So more than not only seventh, you can consider a ninth harmonic, 11th, 12th, 13th, like that. So many, if up to 10th, that is odd harmonics are only harmful over there. After that one, we are going to consider 11, 12 also. So those are harmful only. So up to 10, there is only odd harmonics are harmful over there, because that is a half cycle here it will come, half cycle here it will come. So that is a problem. For the even harmonics, complete cycle it is going to flow half and half, we can do that one. So that is that much. That is also actually harmonics are not acceptable in the system, but in that one the harmfulness is more for the odd harmonics over there. Okay, so more than 10, that is 11, 12, 13, 14, like that, it is going to integer multiple, we are going to consider that one. We can consider up to that 11, 12, and after that one also continuation of that one. Yeah. Okay, so this is the just introduction part of the harmonics here now. If you have any doubts, you can ask, then we'll start the syllabus. Any doubts?
No, sir.
Okay. So then now we'll go for the actual syllabus, that is called harmonic sources for the commercial year. Now actual syllabus means the syllabus I have shown already. Yes, this is harmonic sources from the commercial and industrial load. What is the source? The how the harmonics are producing here. What is the source for that one here? It is some commercial loads are there, some industrial loads also it is going to occur here now. So once we found the sources of that commercial and industrial loads, then we can locate the harmonic sources over there. Location we have to identify over there. Then how the power system it is going to respond to characterize those harmonics over there. Okay, and switching transients will produce us over there. So what is the difference between harmonics and transients? We are going to study here now. So if we have found that one, and what is that effect of harmonics here now? What it will affect here now? So, and how we have to distort here now? Harmonic distortion, voltage and current distortion. Whatever the waveforms I have shown here now, that is called distortion waveform we are going to call here. Next we will discuss about the indices, that is interharmonics, that is series resonance, parallel resonance will come. So during the series resonance, the harmonics are very dangerous. Why it is dangerous and all the things we are going to discuss. So distortion evaluation, how we have to do that one. So devices for controlling harmonic distortion. So whatever the distortion is there, how we can control, and what are the devices for that one, and what is the use of filters over there here now. Active filters, passive filters are there. So up to here, we are going to discuss in this chapter. Okay, so we'll start the first point, that is called harmonic sources from commercial and industrial loads here. First, in the today we will consider commercial. We are going to discuss here now. Commercial means what? It will comes. What are the locations for the commercial loads? See, whatever the houses and all the things are there, we are using electricity. That is called residential. We are going to call that residential. Commercial means what?
Colleges.
Colleges. The city and all the things, the commercial buildings, we are going to call that one. Where the offices are there, complexes we are going to. Complexes सुना है ना? अभी बस स्टैंड के सब complexes है उधर, hotels है, hospitals are there, computer shops are there, some offices are there, LIC offices there. Yes or no? That is called commercial buildings. We are going to call that commercial buildings. To do the work, that is anything, staying purpose, whatever the residential is different, commercial, that is. To industries, load is nothing but whatever the plants are there, manufacturing plants and some anything, we are going to do the product development over there. We are going to design development of product over there. We are going to manufacturing that one. That is industry type. We are going to call that one. Okay. So mainly we are going to harmonic sources from the commercial and industrial loads. We are going to discuss here. So harmonics of different orders generated when connected power system network by different sources here. Whatever the supply is there, it is not only for हमको आया तो बस हो गया, ऐसा नहीं है. So this whatever the from the substation, they are for that reason only they will separate the residential load, commercial load and industrial load. They are going to separate that for them nowadays, because they are going to give one separate line for the commercial, industrial, like that they are going to go over there. So why it is going to happen means, in a commercial building, in a offices and all the things, what mostly we are going to use? Work purpose kaise? Software engineer, suppose software companies are there, that is commercial buildings are there. Okay, how they are going to work? They are going to work in the computers only, na? Yes or no?
Yes.
They are going to work on computer only. Just a minute. Okay, so in the software industries or any commercial buildings, how they are going to work? They are going to work in a computer over there, by sitting in a computer. So they are going to work over there. Okay, so here one mouse I will connect here. Okay, so beside this, this is the monitor and this is the CPU is there. Computer is a electronics device or what? Computer is electrical device or electronics device, that is? Yes. I'm asking to you people only. Any one of you reply. अरे कोई तो रिप्लाई दे दो ना. Hello, is it audible?
Yes, sir.
Is it electrical device or electronics device that is?
Electronics.
Computer is electronic device that is. So for the computer to operate that one, it required AC supply or DC supply inside that electronics component. So monitor is there. For the monitor, I will connect a direct one plug point. I will connect that one. So it will connect here. But here also, nowadays, the monitors have come with adapter here. Adapter के साथ आ रहा है monitors. आपके घर में टीवी है, वो छोड़ दो. Now your house has TV here. So उसके साथ एक केबल दिया टीवी को सप्लाई देने के लिए. उसको अडाप्टर है क्या नहीं? Is there any adapter? Oh.
Yes.
So adapter है क्या नहीं उसको? चार्जर पकड़ो आपको, मोबाइल चार्जर. It has some adapter. Yes or no?
हाँ सर, यस होता है ना.
इतना बोलने के लिए कितना टाइम लगते हैं? So like that, the computers, the CPU has SMPS system is there over there. Inside that CPU, all the CPUs, they have SMPS output. Previously, what was happening here now, in the supply, we are going to use 230 volt, we are going to get over there. Yes or no? 230 volts are there, but to operate the electronics devices, only 10 to 12 volts is enough for that. Okay. So for that reason, we were using one transformer here now. Starting, we have to use the transformer over there. Okay, transformer. Then this is, oh, it is, sorry, only 2 lines only, na? So that is, so transformer, it will convert 230 into 12 volts. Then that 12 volts we were converting into DC by using a rectifier. So like that, this much big process was there previously. But whatever the switched mode power supply is there, that is called SMPS. We are going to call that one switched mode power supply. We are going to call that. Switched mode power supply. We are going to call as SMPS here. किसी के पास कंप्यूटर है तो थोड़ा पूछ सकते हैं, कोई एसएमपीएस गया तो कैसे होते हैं, ऑपरेट नहीं होते बोल के. Switched mode power supply, what it is going to do, directly it will take the input and it is going to give the power supply to the all the devices over here. So we have reduced this usage of transformer part. It is completely reduced here. Completely reduced here. So it is a switched mode. It is switching the power supply from one source to another source. So that is switching, that is going to produce in the harmonics here. Distortion will be produced. So for that reason, the commercial loads also produces the harmonics here now. So industrial, we are going to use some motors. We are going to use. So motors we are going to use means we are going to control the motors over there. So some example, malls, complexes, shopping malls, and all the things you will go visited in the Pune, Mumbai, Bangalore cities. So some elevators are there over there. Steps को ऐसा खड़े हो गए ना, ऊपर लेके जाते हो. Yes or no? How they are going to operate? They are going to operate by a motors. So motor is continuously rotating, but how we are controlling that speed of that motor? We are going to speed drives, controls, we have methods we are going to use over there. So based on that, so that is also, it is part of the harmonics they are going to produce here. So the non-linear loads will be produced by using the electronic components over there. So the non-linear loads such as inverters, FET adjustable speed drive. You can use inverters here now. Wherever the battery supply UPS is there, that places we are going to use the inverter, because from the battery we will get DC. Now that we should have to convert into AC over there. So that is non-linear load such as inverter here now. Inverter adjustable speed drives here. So use of power factor corrections to correct in the industries and all the things what they are going to use. So continuously by running the motors and all the things, the power factor will be reduced over there because of heavy inductive load they are going to use. So what they are going to use, some capacitor banks they are going to use to increase the power factor here now, to correct the power factor here. So because of that one also, it will create parallel or series resonance over there. So resonance will, when the resonance will create XL equal to XC, that is called resonance we are going to call. Yes or no? When XL equal to SC, XC, so inductive reactance equal to capacitive reactance, that is also called resonance we are going to call. See, you are studying the power quality subject, means you should know all the basics of that one. Resonance means what, harmonics means what, fundamental means what, how the load is going to add, SMPS, all the knowledge we is having, they are going to understand. Otherwise, you people have to read 2 to 3 times this one chapter. Then only you can write the exam. So forget about the offline exam, online exam. Only offline exam is there for you. Once again, I am remembering you. Okay. So series resonance and parallel resonance problem it is going to create, which will increase the harmonic distortion. So harmonic distortion will increases because of this, using a capacitor banks and some inductance and all the things by using that one. So it will create a problems over there. Is it audible? Audible है क्या? Is it audible?
Yes, sir.
Yes.
Yes, sir.
इंटरनेट कनेक्शन तो दिए. वो नेट ऑफ किए क्या? आप सप्लाई बंद किए क्या? सिर्फ यूपीएस पीजी से बंद किए क्या? ठीक है. ओके नो प्रॉब्लम. Okay. The process control and solid state power conversion equipments here. So we are going to use the control of the motors, drives and all the things, and some power conversion will be occurs, AC to DC, DC to AC. Because of that one, that is going to use that one. And by using a energy efficient compact fluorescent lamp, nowadays LEDs are using. Okay, LEDs are electronic devices only inside that one, light emitting diodes. Yes, but previously before LED, which lamps we were using? Before LED क्या use करते थे आप? Anyone can you tell? Before LED, fluorescent lamps we are going to use. Yes or no? Tube light. Tube light use करते हैं आप? Use किए क्या नहीं? Hello. Is it audible?
हाँ सर करते थे ट्यूबलाइट.
ट्यूबलाइट, इन दैट वन ट्यूबलाइट, द होल्डर ऑफ ट्यूबलाइट, इधर एक बॉक्स जैसा रहता था, उसको क्या बोलते हैं हम? द बलास्ट वी आर गोइंग टू कॉल दैट. So during the start, the heavy voltage it is going to take over there. After that, it is going to bypass into the main supply. So that is the electronics component, that is non-linear loads. It is where we are going to call that one non-linear. So the tube light that is called fluorescent lamps are replaced by compact fluorescent lamps. ऐसा आ जाता था, देखो होल्डर के साथ ऐसा रोटेशन के साथ एक लैंप आ जाएगा. That is called compact CFL lamp. We are going to call that one CFL lamp. That is called compact fluorescent lamp. In that one also we are using a ballast, that is called compact over there. So energy efficient lamps, that is called compact fluorescent lamps we were using. Because of that one also the harmonics will be produced. Use of AC, DC adjustable speed drives. We are going to use a fan. Actually we have to discuss with commercial. Okay, I have taken the example of shopping mall. Shopping mall we are going to use that one, the elevators or escalator, that is, and lift we are going to use. Yes or no? Those are the speed drives we are going to use to control the speed of that one. That much speed only you should have to go that one. And next, static VR compensator, static reactive power compensation we are going to do. In the reactive power compensation, again we are going to use the reactor, capacitors we are going to use over there. So because of that one also, there is a chance of harmonics over there. Next, the transformers produce very high level of harmonics when they are initially energized. ट्रांसफार्मर मैन्युफैक्चरिंग करते हैं, मैन्युफैक्चरिंग करने के बाद इमीडिएटली हमने सप्लाई दे दिया उनको. So immediately we have given the supply, and that condition what will happen? It will not give the exact output from the whatever that L1 kV to 230 or 240 volt. For the initial condition only, we have to energize, we have to fill the transformer tank with oil and all the things. We have to check the measure of each coil over there. Three phase means 3 coils will be there over there. So we have to energize by giving the supply, we have to energize that one. So after energizing for 10 to 12 hours, it is come for the normal output. It is going to give as per the requirement. So for the initial condition, whatever the energization process is there, so that is, it is going to produce the harmonics here now. Transformer produces very high level of harmonics. It is going to produce over there when they are initially energized. So called in rush current will generate harmonics of several orders here. Several order harmonics it is going to produce during the starting of the what is that one? Energizing the transformers over there. Okay, next we have discussed in the previous, that is rectifiers, inverters are there, chopper circuits are there, cycloconverters are there. These all the things, every circuits or conversions, we are going to use the electronics components only. The electronics devices only we are going to use. Resistance, capacitance, diodes, semiconductors, and all the things over there. So they are going to produce, they all are non-linear loads only. So because of that also, the source for the harmonics we are going to call that. So wherever we are going to use the converters, so the rectifiers, I told that one, in everywhere nowadays rectifiers are they are using over there. Inverters, where we are going to use UPS and battery supply. सब all घर residential loads they are going to, सबका घर में अभी inverter battery supply है क्या? आपके घर में inverter battery supply है?
हाँ है ना, सही इन्वर्टर है.
All the girls, all the people who are having, all of you. But when you go for the, suppose a computer shop में internet cafe को जाओ आप, they have the backup purposes. They have the internet inverter battery supply they are going to use their computers, because suddenly there is a power interruption, and that conditions they should have to run by a battery supply over there. So that is called continuously the commercial buildings, we are going to call that one. In a software companies, they will not get the time when they supply, they will not understand at all when the supply gone, when they supply came, because that much efficient and reliability they are going to operate. So because of that, they are going to use the UPS and battery supplies they are going to use over there. So that is commercial buildings we are going to call it. So they are going to use inverter and battery supply, means it is a non-linear load only. So that will produce the source for the harmonic distortion. That is called source for the harmonics over there. So inverters and rectifiers everywhere we are going to use, and cycloconverters here now, frequency controller we are going to, converters also we are going to call it. Cycloconverters where they are going to use in any shopping malls and all the things. You consider that one. Lift we are going to use, means that is the control of the speed of that lift will be there. Lift system. Traction is there in the electrical train or anything, traction system we are going to use. AC voltage regulators we are going to use. UPSs we are going to use. Battery chargers we are going to use. So these all the whatever the materials, whatever we have mentioned here now, these all we are going to use in the commercial, and these all are used in the commercial buildings and industrial areas only here now. So the sources, whatever we are telling here now, that is called harmonic sources from commercial and industrial loads we are telling that one. These all are in the commercial and industrial areas only we are going to get here now. So these 8 points, whatever I have mentioned, these are the sources for the harmonics here. To produce the harmonic, these are the reasons, or these are the source to produce the harmonics we are going to call that. Okay, so this is the reason how the harmonics they are going to produce here. So these are the 8 points we have discussed here. That is harmonic points we are going to call. So one by one now we have commonly, I have not mentioned this is the commercial, this is the industrial, I have not mentioned that one. Example, UPS battery supply, some places they can use in the commercial as well as some industries also to maintain the offices and all the things. They are going to use here over there. So inverters they are going to use everywhere over there. So some motors are there. You can commercial building, that is shopping mall and all the things, that is a commercial building only. In that one also the lifts are there, everywhere they are going to use. So commonly we have considered it may be commercial or it may be industrial. Commonly we have considered these points over there. In the next class, what we will do, we will discuss separately about this commercial and industrial. We will separately, we are going to discuss over there. First we will take the commercial load, then all the commercial loads we will discuss, then we will go for the industrial over there, then as per the syllabus we will continue over there. Okay, any doubts? Any doubts? Roll number 1, 2, 10, 12, 13, 16, 23, 24, 30, 31, 35, 36, 37, 41, 45, 46, 47, 48, 49, 50, 52, 53, 55, 58, 59, 61, 62, 64, 65, 66. These are the absent numbers. Okay. Any doubts? किसी को कुछ डाउट है क्या? Can ask that one. Tamboli Arbaj. Arbaj Sheikh. Roll number 60. Hello. Roll number 60. Arbaj Sheikh. I will put absent if you are not replying then. Roll number. Okay, we'll stop here only and we'll continue in the next class.